Good afternoon, everyone. Welcome to Android Game Graphics and OpenGL ES versus Vulkan case study. Before we get started, just a couple housekeeping notes. If you have any devices which make noise, please make sure they're on silent mode. And be sure to fill out the feedback for the session at the end. Brief introduction, my name is Nate Trost. I'm a developer relations engineer at Google, working on the Android Games developer relations team. Prior to joining Google, I'd spent a little over 20 years in the game industry, working on a wide variety of platforms. And now I'm working at Google, helping game developers make the most of their games on the Android platform. So our topics for today, I'd like to start by giving a brief overview of Android graphics APIs. That is the low-level APIs, which you use to talk to the hardware on the device. Those APIs are OpenGL ES and Vulkan, and we'll do a little examining of the benefits of Vulkan in comparison to OpenGL ES. From there, we'll discuss how you decide what APIs are right for your particular game. And we'll look at that from the context of game developers who may be using a commercial or open source game engine, or developers who are doing their own engine and technology stack. And then we'll do some Q&A at the end. So there are a lot of different levels of graphic APIs. What we're focused on today are the low-level APIs that are the intermediary between the GPU and your application. Even if you're using a popular game engine at some level, that engine has to talk to the hardware, and these are the APIs you use to do that. And even the Android platform itself at an OS level is using these APIs to render graphics. And on Android, the two APIs in use are OpenGL ES and now Vulkan. This slide really kind of compresses about 15 years of development and rapid iteration. Android initially shipped using the OpenGL ES API. And in those days, the hardware was relatively primitive, and the API was fairly simple. It was before programmable shaders. You had a fixed function pipeline. And overall, there were a lot of constraints, and resources were limited. In fact, OpenGL ES started as a new version of the OpenGL API intended for this new class of embedded hardware that was coming out of the market. The original OpenGL API grew out of Silicon Graphics workstations in the 80s and 90s and encompassed a pretty wide set of sometimes increasingly esoteric features that happened in vertical markets like professional visual simulation and CAD that didn't really make sense for these new embedded devices. So OpenGL ES was a way of kind of keeping a lot of that familiar API while keeping it more compact and suited for this new class of devices. Well, over the years, mobile devices and mobile hardware rapidly evolved, and OpenGL ES had to be updated to keep up with that pace of hardware innovation. OpenGL ES 2.0 came to Android, introduced programmable shaders, and then 3.0, 3.1, 3.2 kind of rapidly iterated to take advantage of all the new features that were rolling out in mobile devices. During this time, in general, there was a bit of a high-level versus low-level evolution of some of these APIs. An API like OpenGL ES is low-level in the sense that you're not telling, hey, I want to draw, say, this model playing this animation in these world coordinates. You're telling the API, I would like to render this set of graphic primitives using these bound graphical resources. But even though it's low level in that sense, APIs like OpenGL ES still abstract quite a bit from your application. A lot of aspects of memory management, of your synchronization of rendering, all kind of happen under the hood in the driver. It's a bit of a black box. And that introduces some overhead, so abstraction cost, and the drivers tend to be fairly heavyweight. You end up having a lot of CPU time, a lot of processing going on in areas that are kind of outside the control of your application. Vulkan was developed to be a lower level specification for a multi-platform graphics API that lets you get a lot more fine-grained in areas of memory and resource management and controlling the synchronization of your various operation draw streams or compute streams. Android decided to choose Vulkan as a successor graphics API and debuted Vulkan support with Android 7 with Vulkan 1.0.3. Since then, Android has continued to adopt new versions of Vulkan as they've become available. Android 9 added support for Vulkan 1.1, and Android 13 added support for Vulkan 1.3, which is the latest version of the Vulkan API. Now, as far as availability, you've always been able to assume OpenGL ES is available on Android. It's just a question of what version of OpenGL ES a given device might support. Now, for Vulkan, since Android 10, Vulkan 1.1 has been a requirement for 64-bit Android devices. And that requirement is going to be updated in a future version of Android for Vulkan 1.3. Android is a very large ecosystem, and there are some subcategories where this doesn't apply. 32-bit devices, including those which are Android Go, may still be only OpenGL ES only. So Vulkan is widely available on Android, but since Android is so big, that doesn't apply to all the categories of Android devices. Now, what that looks like in the real world, in terms of active devices, that is, devices which are actively connecting to Google Play, about 85% of those currently have Vulkan support. 77% of active devices support Vulkan 1.1. And to contrast that with OpenGL ES, at this point, about 95% of devices support 3.0 or higher, which I think is interesting in context because we have finally reached the point in the Android ecosystem where those older OpenGL ES 2.0 devices are only representing about 5% of active devices. So we have reached a point where there is significant support for Vulkan in the Android ecosystem. As far as the future, OpenGL ES is mature, and it is not actively being developed as a core API. You may still find developer or vendors doing their own specific extensions here or there, but OpenGL ES 3.2 was kind of the end point for the evolution of that API. Now, up until now, most features have been achievable in either API. Some may be easier to do in one versus the other, but it wasn't a case of you could only do this in OpenGL ES or you could only do this in Vulkan. However, we are starting to reach a point with hardware evolution where you'll start to find features which may be Vulkan only. The biggest example of that is widespread support for ray tracing acceleration in mobile GPUs. Now, we've talked a bit about the differences architecturally between OpenGL ES and Vulkan, but what are the benefits of Vulkan over OpenGL ES? Why would you use Vulkan over OpenGL ES? The biggest benefits are going to be on the CPU side of things. As we discussed earlier, Vulkan is a lower-less API. The driver is doing less. It's going to be spending less CPU time in the driver. That complexity does move to your application, your game, but you know a lot better about what your needs are. You can tailor to your specific needs in a way that a driver can't. One concrete benefit of that, for example, is in Vulkan you can achieve more draw calls for a given frame rate target than OpenGL ES. If you've done mobile development for a long time, optimizing the number of draw calls and trying to keep them as low as possible could be a significant amount of engineering effort as far as figuring out how to batch things, combine resources, and avoid that CPU side bottleneck that happened from draw calls. And in general, also in mobile development, you're often battling thermal throttling and avoiding heating up the device. And reducing your overall CPU load can help you manage that thermal load and keep a consistent frame rate. On the GPU side of things, there are benefits, but they're probably going to be more limited. With the fine-grained control you have in Android, or in Vulkan, you can potentially improve your GPU utilization, but you're not necessarily going to speed up games which are already GPU bound. Vulkan doesn't magically give you more memory bandwidth for more fill rate. If you've got expensive shaders, it's not going to make the math go any faster. And if you're really pushing the GPU, you're still going to run into thermal limits. So to take a look at how this plays out in the real world, I did some profiling of some sample projects which are reasonably sophisticated game samples on some popular commercial engines. To do this, I took a Pixel 6 Pro running a recent version of Android 13 and used a tool called SimplePerf, which is included in the Android NDK, and lets you do some basic CPU profiling to get time estimates of what CPU time is being spent on different threads and the breakdown of the code within those threads. So for this engine, I know the slide's a little dry, we have a comparison between GLES and Vulkan with a graphics thread. The engine does all its API work with the graphics API on a graphics thread, broken down between the driver, the actual engine code, and then the C runtime library. So the graphics thread spends about a third less CPU cycles, roughly, on Vulkan versus GLES. How that breaks down between the driver, the engine, and the C runtime is interesting. The driver is almost over 60% less time spent in Vulkan versus GLES, but the engine is about 15% more time. And that goes back to what I mentioned earlier. Vulkan does push some of the complexity to your engine that used to be handled by the driver. And that is reflected by the engine side doing more work. But in the grand scheme of things, it's a net major CPU time savings. As far as the C runtime library, it's about 16% less on Vulkan versus GLES. Digging further into those figures, what that really boils down to is memcopy, memset, and like mutex operations. So there's a lot of that is the driver potentially doing less moving of memory around copying, keeping extra copies. So there's efficiency wins there. Looking at sample B, which is a totally different engine, we see kind of similar results. The graphics thread is about 35% less in Vulkan versus GLES. The engine is about 9% more time, so it's a bit more time, but slightly less than the other example. In this case, the C runtime library is doing a lot less copying and memset. It's about almost 30% less time. So these are, generally speaking, representative of the kind of results you could expect to see if you were using a popular commercial game engine on Android, on GLES versus Vulkan. Now, will you get more frames per second? And the answer to that is, it's complicated. And that really depends where your bottlenecks are and also what your goals are. Because in mobile, you may have situations where you're like a high performance FPS where maybe you do have a set of your users playing plugged in with like a gamer phone that has serious cooling. But that's kind of the minority of gamers. A lot of devices don't have anything like that. And you may be choosing to have a target frame rate where you can meet a visual quality target for your game at a consistent frame rate that feels good for the user. And Vulkan's improved efficiency can help you hit that target frame rate. Now, we have talked to some developers where, for example, Vulkan's ability to process more draw calls has helped them do more within their target frame rate. For one developer, they were a little bit CPU bound in draw calls, and Vulkan, they get about high single-digit percentage more draw calls to do things like increase render distance and complexity before they start being bottlenecked by the GPU for their target frame rate. So depending on the nature of your game, you may be able to do more with Vulkan for target frame rate than you can on GLES. Now, what API is going to make sense for your game? And we'll discuss this from the context of using a game engine versus people who are doing their own technology stack. OpenGL ES only, OpenGL ES and Vulkan, or Vulkan only. So OpenGL ES only is still going to make sense for a lot of developers, and it may seem strange when we talk of the benefits of Vulkan versus OpenGL ES, but it's not always going to make sense to support Vulkan. A lot of game developers may have an existing game which is on an older engine with no support or poor Vulkan support, and it may be simply prohibitive to try to add that in the engine, either from engineering resources or the cost benefit simply may not make sense. You may have a game which is targeted primarily at lower-end 32-bit devices, in which case Vulkan support, it may be limited and you're not really going to see any necessary benefit on those devices. Also, a lot of game graphics in the mobile sphere just don't require the demands of high-fidelity gaming. It's perfectly possible to have an engaging, fun mobile game with basic graphics where OpenGL ES is going to be perfectly reasonable as an API, especially for small indie titles. People may be doing custom development where they're writing their own renderer, but they're not super experienced. And Vulkan does require more work. Obviously, if a game engine that you're using, that work is taken care of for you. And that's really where I would recommend OpenGL ES and Vulkan. If you're using a recent version of popular game engines, they really do support both APIs very well. And you can have a situation where Vulkan may be the default on most modern devices, but GLES is still available as a fallback. especially if your game has configurable graphic options. You may be targeting a wider range of hardware, from low-end to mid-range to even high-end flagship phones. And if you've got those sliders or checkboxes for various features, that makes more sense. Now, Vulkan only. If you are sitting down to implement your own render, you're rolling your own technology stack, and you're kind of starting at this point, I would say that we are at a point in the Android ecosystem where it probably does make sense to go Vulkan only, especially if you're pushing the envelope with a high fidelity game. If you're doing that, your min spec is going to require a relatively recent device. And as we saw early on, Vulkan 1.1 has been a requirement for 64-bit devices since Android 10. So looking at that time horizon, we're already at 75% of active devices, and that number is only going to increase over time. When talking to developers, one recent developer has shipped a Vulkan-only title. It's similar to War Chronicles by Com2 US. And they shared with us some of the rationale for why they went Vulkan-only. For them, they were a multi-platform title, and they're also targeting modern PCs and consoles. And they did their own renderer. So Vulkan was the best API fit for the renderer design, and implementing GLES would have been a significant amount of work. Basically, they would have had to do it twice. And due to their relatively high min spec, it wasn't necessarily going to gain them anything. They needed 4 gigs of RAM and relatively recent Mali or Adreno chipsets. So for this developer, they chose to go Vulkan only, and they've recently released on the Google Play Store. If you are targeting Vulkan, there's the question, what kind of requirements within Vulkan do you want to have for your Android game? Vulkan has the concept of Vulkan profiles, which pretty much are a definition for the required extensions, hardware features, or capability limits for a given Vulkan device to meet that Vulkan profile. So on Android, Google has developed what we call the Android Baseline Profile, which comes in a 2021 and 2022 edition. So if you were starting a Vulkan-only title on Android at this point in time, I would recommend strongly considering the Android Baseline Profile 2022, which includes requiring 1.1 of the core Vulkan API. That concludes the presentation part of this talk. If anyone has any questions about Vulkan or graphic APIs and Android in general, hopefully I can answer them.
Hey, so you've mentioned that Vulkan is already working in terms of features for future graphics and stuff. Do you think, or when do you think the coverage in the market for Vulkan devices will be big enough for OpenGL ES to naturally die?
So the question is, when will Vulkan be popular for OpenGL ES to die? The answer is OpenGL ES is always going to be there. It's really about when it's going to make sense for your game, your particular game, to potentially not support OpenGL ES as an option. And that is going to be game dependent. In terms of compatibility, looking to the far future horizon, it is possible in the future that we may use technologies on certain devices or future devices for compatibilities. There's a library that Google develops called Angle, which basically implements OpenGL ES on top of Direct3D or Vulkan. So in the far future, or not so far future, on certain devices, you may find a case where if you are using OpenGL ES, you're no longer talking to a native graphics driver. You're talking to Angle, which is sitting on top of Vulkan. But OpenGL, as far as your app is concerned, OpenGL ES is still available and your game will still run. So I don't see it dying in the sense of it's going to go away, it's not going to be available. It's more just in the future, I think for game developers, it'll make less and less sense to support OpenGL ES.
So that was actually going to be my second question. Are you seeing enough adoption of Angle in the market right now?
Pardon?
Are you seeing enough adoption for Angle in the market right now?
So Angle, for example, ships on Pixel devices. It's not the default driver. There's still a native driver. But it is possible for testing, and I believe we also, in certain cases, games may perform better under Angle than the native driver on Pixel, and Angle is selected. But as far as what happens more broadly, there's a lot of partners, a lot of OEMs doing Android devices, and they're generally going to do what makes sense for them. So I would say that for the most part, at least for the next couple of years, devices are still going to be shipping with native OpenGL ES drivers. But over time, you may find there may be new GPUs, new chipsets where the vendors are going, Angle works as a solution. We're not going to do a native driver for this. And then the game would be talking to Angle instead of a native OpenGL ES driver.
Thanks.
Hi, do you have any data on what % of those 75% of Vulkan compatible devices have buggy Vulkan implementations?
So that's, the question is about data on the driver quality of the devices that support Vulkan. And that has definitely been a common pain point communicated to us by developers. All I can really say to that is we're aware of that's been a source of frustration, and we are working over time to make sure that Vulkan drivers get better on Android, and OEMs and partners work on improving quality. One of the complications is due to the diverse ecosystem, of course. Sometimes devices may ship with drivers, and the GPU vendor may have a later version of the driver that fixes problems but doesn't make its way back to the device. And we know it's a source of frustration to developers, and we talk to OEMs, we talk to the GPU vendors. So it's one of those situations where I don't have necessarily a good answer for you other than we're aware that it's a frustration, and we are trying to make sure that devices ship with the best drivers possible.
In terms of being a developer, like how would you decide whether to flip the Vulkan versus compatibility OpenGL switch? Like, is this device good enough to have a good driver or not?
So I would say the question was where you decide to flip the Vulkan switch versus GLES. And I think you can view that on two different axes. There's that capability axis, and then there's that quality axis. So the Vulkan profiles and the Android baseline profile, I think, are a reasonable way to kind of encapsulate the capability aspect. I know we've talked to developers for the quality aspect. In the field, they may maintain kind of a list of an allow, deny list for Vulkan, where they will fall back to GLES if they run into problems in the field on a particular device. But developers kind of manage that on a case-by-case basis. We don't have any type of ability for that at a platform level.
Thank you.
Hi, do you expect Web GPU to affect the decision about Vulkan or OpenGLS?
So Web GPU compared to Vulkan or GLES. Web GPU, I would say, is a slightly higher level API, and it may make sense for some game developers to use it. How that would work in practice on Android is there's an open source library called Dawn, which is a Web GPU implementation that can use Vulkan as the lower level implementation. So Web GPU to me, in the context of developing an Android application, is like, it's a little weird to call it middleware, but it's almost like a higher level abstraction that may be less work to implement a renderer on, but you're still going to be talking to Vulkan, because that's probably your best path to using would be to use a library like Dawn that ultimately talks to Vulkan.
Thank you.
Hey, when you have tested, have you seen how much the power consumption difference is when using Vulkan versus OpenGL?
The what?
Power consumption.
Power. Measuring the power is really noisy. We've had a wide variety of outcomes, and that is something I know is being looked at internally. So I don't want to speak to that in depth because it's really kind of a complicated question. I know we've had, it's complicated would be the short answer, unfortunately.
Hi, are there any special considerations that should be made in the OpenGL versus Vulkan thing for Android VR devices?
So Android VR devices, not that I'm aware of. I think in general, with VR, since you really want to maintain a high target frame rate, I think Vulkan makes a lot of sense. And typically speaking, I think, and again, I don't want to speak for non-Google companies, but I would hope that they are pushing to maintain updates and addressing developer feedback. But I would think that Vulkan, I think a lot of VR developers are using engines which can use Vulkan or GLS. But if I was developing a custom VR stack, just as far as trying to minimize latency and maintain a high throughput, Vulkan would definitely be my first choice. If there are no more questions, thank you all for attending. Our main developer site is developer.android.com/games. And as far as Vulkan and other gaming topics, that's kind of our main landing page for all game development resources on Android. Thank you very much.